1. Greetings and welcome. We're talking about ellipses today, and last night's homework was on page 638. In fact, tonight's homework is also on the same page, but we're looking today at question 17. So the objective here was to write the equation of this ellipse, and let's first gather some information. I, for instance, know my center is h comma k, right? And my center I can read right here, so that's going to be -2, 0, right there. Let's see what other information I can gather. Now, this is one of my vertices. So this distance, is this going to be A or B?
B.
How do you know?
It's the shorter one.
Because it's the length of the semi-minor axis, because this ellipse appears to be much longer in that direction than it did that direction. So we could also define that B happens to be 2. I could find a proper distance using the distance formula, or I could just realize that those kind of y coordinates are 2 apart from each other. We also could gather the distance of this, which is A, and because this appears to so perfectly land on a lattice point of the grid, I think we could just figure out that A equals 4. I'm fine with just reading that. And I can't figure out the distance C unless I actually do my little formula for a squared b squared, but that's going to show up a little bit later, so I'm not going to worry about that. I'm just trying to write the equation. So the equation of ellipse, oh, one more thing I have to gather. Is this horizontally or vertically aligned, oriented?
Horizontal.
This is horizontal, all right? Because that's going to determine which standard form of an ellipse I use. So here's standard form for the equation of an ellipse. I'll write it all out. So horizontal, the a squared will be in the denominator of the x fraction equals 1. There we go. So let's plug in what we know, and we're not going to solve for what we don't because we're writing the equation, and that's it. So this will be x minus a -2 or plus 2 all squared over a squared is 4, so 4 squared is 16. Plus y minus k squared, y minus 0, or I could just write that as y squared instead of writing the whole y minus 0 squared. Yeah, we'll just write it as y squared. I want you to be familiar with kind of a simplified version of this. Over b squared, b is 2, so 2 squared is 4, and equals 1. So there we go. So that was reading some of the information off of the graph. We'll talk about finding c later, but if you wanted to find it, you would have used a squared minus b squared equals c squared, which is kind of like an anti-version of the Pythagorean theorem there, a little bit going on like that. So let's see, scrolling down, for problem 21, the instructions say, for each equation of an ellipse, find the coordinates of the center, foci, whatever we want to call it, foci, and vertices, then graph the equation. So let's talk about this equation here. So first of all, what is h equal to here? 4, because it's the opposite of that number. K is equal to -6. A is going to be the square root of the larger denominator, so square root of 16 is equal to 4. B is going to be the square root of the smaller denominator, so that is 3. And also, what way is this oriented? Horizontally oriented, and I know that because the larger denominator is under the x fraction. Here we go. So let's find our equation, or our value of c. So a squared minus b squared equals c squared. So let's plug this in. So a squared is 16, minus 9 equals c squared. So let's see, that's 7 equals c squared. So c is equal to the square root of 7. Well, technically, algebraically, c is plus or minus the square root of 7, but since c is representing a distance, I'm restricting it to just a positive version there. So let's see, what do I have to do? We got to find all of our little facts. So let's see. The center is at the point 4, -6. The vertices, verts, are going to be, let's see, this is horizontally oriented, so that means I'm going to add and subtract the value of a to the x coordinate. So I'd have 4 plus or minus 4 comma negative 6, which I'll actually evaluate that out in a second. And for the vertices on the semi-minor axis, I'm going to add and subtract 3 to the y-coordinate since that was the shorter distance. It was not vertically oriented. So 4 comma negative 6 plus or minus 3. So let's actually evaluate those. So 4 plus 4 is 8 comma negative 6. 4 minus 4 is 0 comma negative 6. Negative 6 plus 3 is negative 3. And negative 6 minus 3 is negative 9. So those are my vertices. And for my foci, right? We can add and subtract the value of C. Which one do I add that to, guys? How would I know?
The center?
Which coordinate of the center?
X.
Yeah, we'd add it to the x because this is a horizontally oriented ellipse. The foci on a graph, by the way, always exist somewhere on the major axis. All right, so that's why if it's horizontally oriented, we'd add and subtract C to the x coordinate. So plus or minus, that's not a very good plus sign, plus or minus the square root of 7, comma, negative 6. And in fact, that's fine, just leaving it that way. So those are those. And let's see, did they want us to graph this guy? I think so. Yeah, they did. Let's see, I'm going to see how quickly I can open up my Geomatus Sketchpad and get a nice little grid here for us. File, new sketch. Let's see, so based on the center, let's see, grid form. We'll do a square grid here. Based on the center and these coordinates, it looks like vertically or horizontally I have to go over at least to 8. And it looks like horizontally I only have to go over to 0. So it looks like it's mostly kind of existing between 0 and negative 8 horizontally, or sorry, 0 and positive 8 horizontally. Vertically, it's between negative 6 and negative 9, so it looks like I should probably be down in this 4th quadrant primarily. That looks good. So I'm just going to grab a snapshot. Actually, let me stretch this out even more. There, now it's even cooler. And, oh, I got to go all the way down to negative 9 though, don't I? There we go. Snapshot. Wait a minute. Yeah, okay, that's fine. That's good. So paste that in here. And let's see, let's plot some points. So our center exists at 4, negative 6. So over 4, down 6, right there. And you could plot by these points, but I actually wouldn't. I would rather plot using just the A and B. So A was 4, B was 3, and it was horizontally oriented. So I'm going to go over 4, land there, backwards 4, land there, up 3, land there, down 3, land there. And then I'll draw kind of each. Usually I'll draw one quadrant at a time. Let's see, since the radii, quote unquote, are only differing by 1, right? It's 4 and 3. It's somewhat of a more circular ellipse. It's not super elongated. We'll talk about that later today, the idea of eccentricity, which is kind of a measurement of that concept. In fact, I'm going to cancel our little hand-drawn thing, which is, I'm glad I showed you how to do that. But let's actually draw a really fancy one. I think I have to define it by center, and it'll be a oh so beautiful ellipse right there. Ta-da, ta-da. So, and now let's figure out where our foci exist. So I would add and subtract the square root of 7 to the x coordinate. Square root of 7, could someone give me an estimate on that, like just your guess? How would I estimate that?
2 point something.
2 point something, right? Square root of 4 is 2, square root of 9 is 3, so it's somewhere between 2 and 3. Square root of 7 is closer to 9 than it is to 4, so it's probably like 2.6-ish, something like that. So I'm going to go over 2 and a little bit more than half, and backwards 2 and a little bit more than half. So those are probably where my foci are, just like so. So there's my ellipse. It actually looks like it'd be like some weird, like, crying baby, like, wah, right? If it had like a red mouth, and he'd have like this little tongue right there, and you just go, wah. Questions? No? Okay. So let's see. Let's look at one last problem, which is kind of like a problem about clues here. We're going to talk more about these in today's video. So they gave us some facts. All right. So they told us that the foci are at -2, 0, and at 0, or sorry, it's +2, 0. Okay, so these are the foci. And they told us that A equals 7. So they actually, the directions say write the equation of the ellipse that meets this set of conditions. So let's see, what do I actually need to write the equation of an ellipse? I need to know H, K, I need to know A, which I do, is 7, and I need to know B. Those are what I actually need to know. So let's see, using this information, could I find HK? Could I find the center? What are your thoughts? How do you find 0, 0?
Because it's right in the middle of 2.
Right. So the foci, remember, are plus or minus the distance C from the center. So the center must be the midpoint between the two foci. In fact, the center is also going to be the midpoint between the endpoints of the semi-major axis, as well as, sorry, the endpoints of the major axis and the endpoints of the minor axis. Right? So, so I could just find the midpoint formula, but I agree that it's probably kind of just as easy to read that right from there. H is going to be the average of -2 and 2, which is 0, right? And K is the average of 0 and 0, which is 0. Look, man, I boxed that before I even wrote the number. A is 7. So let's see. Can I find B yet? How could I find B? Well, remember we've got this additional equation, which is true for ellipses. I know A. Could I find C to help me find B?
Would you have C?
I know the foci, but I don't know the distance C.
You grab it first.
You could. Well, think about the foci. The foci represent what? Or how would you plot the foci if you knew the center?
Would you just go like over
How many units?
over 2 and then up 0 from the center?
Right, we would move C units to the right and C units to the left. Actually, wait, that brings up a further question. Is this horizontally or vertically oriented?
We can't figure it out.
If we drew a picture, we could figure it out, or I might argue that we could even visualize it. Let's see, looking at the two foci, it's the x coordinates that were different from each other, and the foci exist on the major axis. So since the x coordinates were the ones that were different, it must be horizontally oriented. Is that logically sound? Do you guys?
Yeah. That makes sense.
All right. So that's good to know. And let's see, the foci are C units away from the center, right?
2.
So this point is 2 units away from, let's see, 2 minus 0 is 2, right? So if I do the absolute value of that difference of this coordinate and this coordinate, that would tell it to me. Another way you could have found C is it would be half the distance that the foci are from each other. So it would be 1/2 of, let's see, 2 minus -2 is going to equal half of the absolute value of 4, which is half of 2, or sorry, half of 4, which is 2. So You could actually have found C a couple different ways if you wanted to find the distance between these 2 points. And notice, because these were existent on a horizontal kind of line, I wasn't doing a full distance formula. I was just finding the distance between these kind of in a one-dimensional concept, which is just subtract the numbers, take their absolute value. Because recall, absolute value is actually the distance something is from 0. So it is kind of a type of distance formula, just subtracting those coordinates. So let's plug in what we know, solve for what we don't. A is 7 minus b squared equals 2 squared. So negative b squared equals 4 minus 49. So that would be negative 45. Is that right? So b squared is equal to positive 45. And then I could root both sides. And I would technically plus or minus. Algebraically, there will be 2 answers here. Geometrically speaking, there's only one. We're only interested in the positive or the principal root. So the square root of 45 I could break down into 9 and 5. Man, I just threw a whole bunch of stuff at us. I reduced the radical where I found the largest perfect square that went into 45, and it went in 5 times. Square root of 9 I was able to simplify to be 3. So that's the idea of reducing radicals, which is an important skill. So that's the value of b, 3 square roots of 5. So now we can write the equation. And by the way, I want to point out, it was important that I knew that it was horizontally oriented because otherwise I'd be plugging it into the wrong version. So let's see. So our equation is going to be x squared, x minus h was 0, over a squared, because it's horizontally oriented. A squared is 7, so a squared is 49, plus y minus h squared, or just y squared, over b squared. Now, I actually wouldn't think of 3 roots of 5 and then squaring it and getting 9 and then times 5 and 45. I would just square this version of b right here. So it's just going to be 45 under here, equals 1. So with those couple of facts, we were actually able to logically deduce lots of information from them. You might not have thought it was enough to define a unique ellipse, but it was, in fact, sufficient. So thanks for watching, friends. Have a great day.